5. So my name is Dominic. I've been working for different companies over my career, mostly after a short period as a research engineer in France. I've been working in Germany and in UK, in US, in different areas. I just left recently Intel, and so I can speak quite freely without having a band of lawyers behind me, which is something very new for me. So what is about today? I just wanted to start to look at where is the embedded market. What is very clear is that open source is already owning the embedded market. There's no discussion about that. These data are from 2017, and if we would look at them, with a bit more updated, it would be actually worse. There's more and more open source in the embedded market. It's a bit like in the cloud. So what is the real question of today's talk? It's about, could open source gain the control of the safety security domain as it did for the cybersecurity? I was chit-chatting with a guy in the conference before, and I told him that I started to do a talk on cybersecurity on Linux about 15 years ago. The room were empty. Nobody was interested. And suddenly it became a panic, and everybody was in, and the room were full. For safety, it's really the very beginning today. Safety is a very closed market, and it's currently mostly controlled with dedicated operating systems or with no test. QNX, for example, in automotive being one of the candidates. So, what is really safety? Safety is defined by a number of rules, which is concentrating on software that could harm people. So you can harm people in different ways. The very easy to understand is a car that would be self-driving and that could decide to get off the road. But it can be done in different ways as well. For example, a telecom infrastructure where calling a fire brigade or a doctor would not be possible is also a safety risk. Electric companies that could cut the power to a hospital is also a safety risk. So there are quite a lot of areas where we have safety issues. They are typically standardized and tend to be put under the name of FUSA, functional safety. We have already open source which has entered domain under the radars of functional safety. The first one has been telecom infrastructure and internet services, to which I have been actively involved over the past years. And some other area like financial industry has also been completely overwhelmed by open source, and road and rail, for example, traffic control. So a lot of people are thinking that functional safety cannot be covered by open source. In that way, they are certainly quite wrong, because it's already done in numbers of areas. I remember the time when we had to really push quite strongly to be able to use open source in telecom industry. It was considered too dangerous. Today, it's normal. Nobody even wonder. We are using soft switches. We don't even use hardware control switches anymore in the infrastructure, and we still pass emergency calls over them. Same for internet services or financial industry. 95% of the financial industry and financial transactions over the world are done over Linux, and this can harm a lot of people as well. And I put a few pictures of air traffic control. It's quite amusing to hear people telling you that we cannot do functional safety, thinking that the air traffic control of most of airports are actually running under Linux. So, why is functional safety compliance complex to achieve? The question is to be split in two areas in functional safety. The first one is, can I do a software which is safe from a functional point of view? And the second point be, can I take the responsibility of making that software? And you really have to split the two questions quite clearly. I will give as an example a discussion which happens a few years ago with a guy from a major automotive manufacturer who was saying, you know, with software we could, especially with assisted driving, we could improve and reduce the numbers of deaths over the road. You know, numbers of people killed by our cars. And he said to us, the question is not to know how many people we are killing per year. We know exactly. The question is that, could we reduce it? The answer is yes. But the challenge is who would be responsible of these killings that would remain if we improve the situation. And so in functional safety, it's always a very difficult point, is who is going to sign that the software which has been written is compliant with the regulation. And the regulation will vary a lot depending on the industry, even if most of the principle remains the same. And as you can see, that is extracted from the regulation for automotive. It's complex. Just the vocabulary is taking a complete book. It's written by technical lawyers and business people who, in one way, are not really willing to see the current ecosystem changing. So, what is really functional safety? First, there is no such things as a compliant hardware, a compliant operating system, or a compliant middleware in functional safety. You will see that a lot over the marketing documentations, but it's not real. You can only certify an entire system. So that will include the hardware and the software. And potentially, one thing that is quite often forgotten is the firmware which is running on the hardware. A question in the previous presentation was, that latency is only for one CPU. It's a very, very good question. I was working for Intel only a few months ago, and I know that at Intel we have never been willing to certify CPU with more than one core. One big project did it with 2 cores for Intel. And the reason is that the firmware which is dealing with cache currency sometimes will increase the latency and put it completely out of control. And that's independent from virtual machine or not virtual machine, okay? That's just real world. So the certification of the hardware and software is really what you want to achieve. What is the definition? It's pretty simple. You have to respond correctly to input and event, and the response of correctly will vary depending what you want to do. In a nutshell, you can qualify 2 big sort of systems in functional safety. The first class are the systems that will detect that an error has occurred and will warn the user of the error. The good system for those who are old enough to remember that was the DS-23, where you had a big red switch that was coming on when you had no hydraulic. The reason is that the DS was the first car when hydraulic would go down, you had no steering, no gearbox, no shock absorber, and no brakes. So it was really time to stop. This is still valid. The concept of warning the user is a very applicable system. For example, in cars, this is ASIL B, and currently all the cars which are on the market, including the one with pseudo self-driving facilities, like the Tesla or the BMW or the Daimlers, will actually be ASIL B, which means that they are going to warn you if there is a problem. The way of warning you can be different depending on the cars. If I take the example of a big Bavarian manufacturer's technique is actually to switch completely the cluster, Okay, the cluster, for those who are not used to vocabulary in English for cars, is actually le tableau de bord. That will be switched off. And that is indicating that nothing works, and it's up to you to actually take control of the car. It's perfectly acceptable. In some other area, you want to have systems that will take an intelligent actions which will be automatically capable to put the system in a safe position. So we take a self-driving car as an example because it's easy to understand. It means that the car detecting a problem should be able to slow down and stop in a safe place somewhere on the side of the road. So two classes of system. Now, in all the industry, yeah, it's a type of degraded mode. It's more than that. Degraded mode would be more that you slow down, you warn, and you let the user do it, and that's what cars do. They typically go to 60 kilometers per hour, and they assume that at that speed, not too many bad things could happen. No, in that mode, you would really have to go further than that. You would have to take the action to put the car in a safe position automatically. There are very little systems which are ASIL D. In reality, in cars, it doesn't exist. Now, we have the same in all the industry, medical, energies. Now, they are all driven by different standards. So there is an umbrella one, which is a 61508. And that's the umbrella for FUSA. It's a pain to read it. But it's worse if you are looking at that business. The other one are probably driving exclusion depending on the industry. One that did a lot of noise recently has been the automotive one. Interesting for the people who will read the automotive ones, there was a special section for motorbikes, to which I had recently a discussion with a guy from BMW who told me, if you are stupid enough to drive a motorbike, you should know it's dangerous. So forget about functional safety. But you have them for medical, for household, and for agriculture, for railways. Different standards will always coexist depending on the industry, and it's mostly a self-certification issue. So it's important to realize that in one way, it's up to the manufacturer to sign with his blood that he's taking the responsibility that the system is safe. Now, you have to go through a certification office which act as a peer reviewer, but it's your job to justify it. Now, I just take the case of automotive because it's an easy one, and I've been working in automotive recently, so I had all the documentation in hand. You have different class of what they call the severity, so how bad is a problem, okay? If the light which is telling you how much petrol you have in your car is not working, it's not that bad, okay? If the brake stops to work, potentially that's more serious. Then you have what they call the exposure class, which means that how likely is the event to happen? Okay. It's less likely to have something bad happening on your brake than rain to happen and your whip not to start. Okay? If it rains and you have an auto detection system, your whipper should start if you have an automatic facility. And that's pretty common, that rain will come. So the exposure will define how high potentially is the risk. And from that, you are going to classify where you have to be. So QM is what is called quality manage. More or less, there is no functional safety. And then you have A, which is almost nothing. B is what we see for most of the feature today in cars. And D would be what you would have to do a self-driving. You notice that not many things are in D. C is almost never used. So in reality, in car industries, they use B and D. The rest is quality manage, which means you're going to be able to isolate it. Now, you're going to have to justify why you isolate it, and that's very difficult. So how are you going to do that? First step, you are going to have to really do an analysis of your system. You know which part must be high quality for functional safety, and you're going to assign a safety integrity level to those parts, okay? And so if you are in a generic system, it's a SIL. If you have a cars, it would be ASIL. And from one low level to high level. As I've said, we tend to use mostly 2 levels in most of the industry. It's going to be fault detections or fault recovery. You have to get a rigorous development process, and that is really the pain part for open source, because you have to justify it. And you have to have your safety standard to state the objectives that you want to achieve. So you have quite a bit of documentation. Historically, that has always been assumed to be a V model. And the V model is incompatible with open source. And so it was pretty common to hear that functional safety could not be done with open source. The challenge was, as I've said at the beginning, that a lot of industry are doing safety functional today with open source. So the real question is a V model mandatory in the standard? The answer is clearly no. The standard are, especially the latest release, are definitely open, even if most of the training you will find, most of the documentation, and all the tradition of certification is based on V model. It's not mandatory. The standard are recommending and advising. They are not telling you what to do. As I've said, you are the one signing with your blood that the system works. And you are the one, when I was a CTO of a company, that would have gone to jail if things would have gone wrong, okay? But you are paid well to sign, so you sign and you go to jail if something goes wrong. Fortunately, generally it doesn't. And the standards are evolving. They have done a few big changes in the recent time. The first one, they have allowed to reuse software which has been on the shelf. And they have different names, so component reuse. They are starting, and that's a very beginning, to take some new risk, like connectivity, cyber risks, and complexity. As I've said, the V model is assumed, and a lot of tradition in the functional safety was to do a mathematical proof of the software. Now, those who think or dream they can do a mathematical proof with a multi-core modern CPU or with artificial intelligence engine, okay, they are big dreamers. Now, if you believe you can do a car that will go by itself on the road without artificial intelligence, you are still a dreamer. So the real world is that to do the new feature we want today, we are going to have to accept fundamental changes. The other domain that will force changes is the cyber risk that we will have to take into account, which are enforcing to do update. And update is the nightmare in functional safety because an update is a change. So they have introduced the concept of in and out of context. So in context is that you are really designing your software by yourself and you build it for functional safety. That was a traditional world. Out of concept is that you take software from outside, which was not designed for functional safety, and you validate it from away. And they have different names. In avionics, they call them PDS, and in automotive, they call them COTS. The model is the same. You reuse an existing software. I want a file system. Do I take a file system that was written for a telephone, or do I invent my file system because it's something that I need to have because it will be in a plane? Your validation model has potentially 2 paths. You can do a proven in use approach, so the software has already been used in functional safety in one domain, and so it's proven in use. Or you can make a set of assumptions that the initial design is compliant with what you want it to do. In both cases, certification is a hurdle, and both options are slow. Some extra problems come, for example, in automotive industry, where the QM, so the software which is not functional safety reliance, still has to be developed with a standard which could be applied for the rest of the project. And that's a problem with open source, because you have to prove that the development process is following very strict rules. So Linux kernel is easy in one way. You have to write a bit of paper, but the process is very well known and is very strict. But for some other part, it's not. Is glibc developed in a compliant model? Tough question. And you have a lot of middlewares that you are using like that are very difficult. They are developed by a very small team, and they may do exactly the job you want, but you don't really know how they were developed. A stack for communication, for example. So typically one problem you have to remember if you go Fuser on open source is that you will have to justify the development process even for modules which are not Fuser compliant. Will open source, and especially Linux, get in the majority of open source? The answer is for sure yes. Why? Because it has done the same everywhere where it has gone in. Every time Linux has gone in a market, it has taken the market. Why? Because it does a job. And at the end of the day, most of these risks are not that stringent. We talked a lot about real time. In reality, real time is rarely very, very strict. And if you do it, you can do it with other way, like a small microcontroller in a corner. You know, it's not that often that you have to really respond to interruptions with 100% accuracy within 10 microseconds. Systems have to be reliant to fault. And so if you plan for the fault to happen for a hardware failure or a transmission failure, then it means you can also support that same fault for a software misbehaving. No. If you are capable to lose a packet on a CAN network that has to be retransmit, you are capable to lose an interruption in your software. No, the recovery mechanism is the same. So little doubt that it will make it, but how? The first thing is that Linux is not the only one to be used. You have smaller systems which are available on open source, small real-time system, one well-known are Zephyrs or Acorn. You have hypervisor which are available in open source or in non-open source, which can simplify the problem. They don't delete the problem, okay? They can simplify the certification. Surprisingly, quite often they increase the complexity of the system, which at the end may not be a good solution. You have a number of strong initiatives. One is SIL for Linux from ASIL, which has been running for a long time. If some of you know McGuire, he's been talking in conferences about functional safety for Linux for the last almost 20 years. And he's progressing quite well. He's been trying to prove by a statistical model the applicability of Linux in critical world. That's what he did. And he succeeded quite well on Intel architecture up to 2 cores. Not more. Up to 2 cores, it was pretty good. You have the ELISA project from the Linux Foundation, project which is progressing very, very slowly, let's be very honest, and may never provide anything very serious, but at least it goes in the right direction. And quite often, like we've seen in open source, you don't have a one solution. It's probably a direction that gets, it's a wave. You have at least 2 big names of distribution which have joined the ELISA project, Red Hat and SUSE. And you have an initiative like I've taken Red Pest because they are colleagues and friends from Lorient, which came originally from the automotive world and now are also working in maritime world, which are driving domain in those areas and solutions which can help to do it. Now, why it will move? Very clearly because the risk factors are not static, and so the V model and the mathematical proof will not be applicable for very long. We have very sophisticated multi-core CPU, where we have very complex firmware which are running that nobody knows how they work. We have design which are validated by ARM, for example, but ARMS is not the one doing the chip. What happens at the time they do the real chip? We have this black box firmware, which are really tough. We have software complexity, especially 3D user interfaces. GPU is a very serious hurdle in functional safety. Now, there are companies which claim to have done an ASIL B OpenGL. Yes, I'm sure they have the certification, but someone will have to sign. You have the connectivity, and you have the cyber risks that is going to require to upgrade the software very fast and very often, which is fundamentally completely incompatible with current processes. So what is going to be the side effect? The standard will have to evolve or will be ignored. That's what happened in the telecom world. In the telecom world, we had big standard on how to write a switch, how to make software for a switch, and arrived a time that we just ignored them. And we wrote the switches in a complete different manner, and we deployed telecom infrastructure completely out of any existing standard, because the existing standards were too slow, too expensive, and didn't allow us to provide the feature we wanted to provide. So that could be one way. So either they will evolve, either they will be ignored. Will we pass? Yeah. Certification? Yes, you can pass certification if you want, and some people have done it, including in cars, in ASIL B, using the fail-safe mode. So the model where you actually detect a fault and you warn the user that there is a fault. But you have to really know what you want to do, and you have to change things. One big problem you have is that you have to be able to really know what you want to do. You have to get your real Linux expertise. You have to be able to build your software in a very reproducible mode. We were talking about Yocto before in automotive project. We learned that that's not an easy one, because redoing reproducible software is very difficult with that solution. But there are other solutions which are available, typically, like software factories that allow us to rebuild software in a more reproducible way and in a more granular way than projects like Yocto. We have in open source a lot of projects where the development process is very chaseable. Linux kernel being one good example, which means that we can actually submit that for certification. We have very detailed review at each level, and we have a very fine subsystem isolation. Most of people will need commercial offering. It requires such an expertise today that getting in the FUSA world without the help of specialized company is most likely an extremely high-risk area. It's not something where today you just can download from the internet the distro and build your stuff and go for compliance. You're going to be thrown out. And some domain will remain out of reach to that world, especially to Linux. The first one being very short reaction time in hard real time. The reason being that the CPU on which Linux is running tend to multi-core with cache, and those tend to have an interruption jitter on exception, which can be pretty high, including with hypervisor. Now, don't dream. Okay, this is a CPU which is sometimes reorganizing its cache and could stop you to do anything for quite a few microseconds. When I say a few, it could be up to milliseconds sometimes in some extreme cases. So this is something you're not going to get out. And so if you really need that reaction time every time, like for example for an ABS, you are unlikely to use Linux, because the CPU which are running Linux and the way Linux behave together, both of them are actually not that good for that job. And very small system, because we have never been able to run really Linux on very small system, but OS like Zephyr could do that. So what are the most likely scenarios for functional safety and operating software? We are going to start most likely with side industry. The first one which went in, I said telecom. The second one, which is already using Linux a lot, is medical. Okay, most of medical devices done today are using Linux. But there are some which are coming quite strong. Energy management. The maritime world, I've named Red Pest before, but that's an area where the standards are less. It's not that they are less strengthened, but there is no ecosystem where you have a buyer, you have companies, you have management which is used to do stuff in one way and don't want to take risk. They start from scratch, they have to fix a problem, and so they don't have a legacy that they have to look after. As I already mentioned, you will need to take software from specialized companies in operating system, and some domain, because of legacy, will come later. I believe that automotive will come a little bit later. They have started, but they will come a little bit later. Avionics will likely be the latest, because they have already solution working. They have already developed the ecosystem. They are used to spend that amount of money for doing it, and it's part of the plane. And some people will come in the game and disrupt completely the system without respecting any rules. And so the other one will have to move. That's what we had seen previously in telecom. Pushing people who are using the old standard de facto in obsolescence. With this, we may have 1 minute.
Yes, one question in the room.
No, there's no problem.
Thank you very much.
You're
I think
welcome.
we can upload.
Thanks.